Hello and welcome, I'm your Code Monkey. In this lecture we're going to handle player movement. And as we're doing that, we're also going to talk about something extremely important, whether to make your multiplayer game server authoritative or client authoritative. Both methods are valid, I'm going to showcase both of them, and then it's up to you to decide which one best fits your game. Okay, so the basic setup is already working. We have the network manager set up. So over here with these two builds, I can start this one as a host, this one as a client, and yep, both of them are connected. So far so good. However, if now I move with some input, yep, both objects are both on the exact same position and they are both moving with the same input. And of course, the movement is all local, so nothing is being synchronized. So let's handle this. For the first problem, we just need to make one small change over here on the player script. Like we saw right now, the input is moving both players, but we don't want that. And the movement is down here. We have our update where we are handling the movement and interactions. Both players have this script, so both players are running this code, but we only want a player that is local to that build to run this code. And how we do that is very simple. On the network behavior, we have a bunch of nice properties. We can check out a bunch of is things. So we can check is client, is host, is local player, is owner, is server, and so on. And basically for this one, in this case, for checking if this player is the local player, we can check is owner. That is because the player game object will be owned by the player when that player joins and that object is spawned. So if we check is owner, this one is only going to be true for the local player. So we only want the local player to run this. So over here we can just check if this one is not the owner. If not, then we just return. So this one will only be true for the local player. So only the local player is going to run the movement and the interactions. Okay, that's it. That's the only change. Now if we test. So here are the two players. And if I move just this one up here, yep, it only moves one. And down here, and yep, it only moves one. Okay, great. However, of course, as I move it, the movement is still not being synchronized. The client down here still thinks that the host is over there on the spawn position. Same thing on the host, still thinks that the client is over there. So let's synchronize the movement. And we can do this using a super simple component. Let's go over here onto the player prefab, and we can just add the component, search for a network, and let's add the network transform. Basically, this will synchronize all of the transform data. We can even use these checkboxes here to help reduce the bandwidth by only synchronizing the things that can actually change. For example, in this game, the player only ever moves left, right, forward, and back. There's no jumping involved in this game, so there's no need to synchronize the Y position. For the rotation, we're only going to rotate on the Y, so there's no need to synchronize these two. And for the scale is never going to change, so we can also not synchronize these two. Okay, so this will synchronize the transform and only the things that actually matter. And this is where the question of server versus client auth comes in. The way this component works, this one is only server authoritative. So if we try like this, let me go back outside, save the changes, and make a build. So here are both builds, up here the host, down here the client. Now if I move on the host, yep, there you go, the host does move, and it does get synchronized over there on the client, so that's great, that looks like it does work. However, if now I go down here onto the client and I move, and nope, the client doesn't even move. I'm pressing the buttons, the animation is actually playing, so the input is being received, but nope, there is no movement. That is because that component, the network transform, that one is only server authoritative. Meaning that only the server, which is also the host, only this one has authority to move this transform. If this local client down here tries to move it, then basically just snaps back to where the server says that object is. Like I said, I'm going to showcase both methods because both methods are valid. Let's begin by looking at the client auth method. And for this one, we are going to use a different component. We can go into this page, so onto the docs. You can just go into the docs themselves and go into the netcode for game objects. Then go under components and go into the network transform page. So on this one, if we scroll down here we can see a client network transform. This is exactly what we want. It allows for client authoritative gameplay. So we can either import the entire samples from Git or just down here we have all the code. So let's just go ahead and copy all of this code. Then over here in the editor, let's just make a new C# script. Call this the client network transform. And then over here, just select all and paste the entire code. That's it. So here, basically all it does is it just extends the network transform and just does an override on is server authoritative and returns false. So this way, this one is no longer server auth and works as client auth. So now if we select the player prefab and over here, let's replace the network transform for the other one. So the client network transform, and let's set the syncing on the same thing. Okay, that's the same setup. So we just changed the component. Now if we test this, so up here is the host, and as I move it, yep, it does get synchronized. And down here the client as I move it, and yep, now this one does get synchronized. So we can move both independently and both of them are being synchronized. Alright, awesome. So this is how you can make your game client auth, meaning that the client has the authority to make changes on the server state. This has some pros and cons, which I'm going to talk about in a bit. But before that, let's actually look at how to make this entirely server auth. Basically, in order to make this server authoritative, we need to make sure that only the server can move the objects. The client can request to move, but it's up to the server to decide whether to actually move it. So over here on the player script, let's go down into where we are handling the movement. So on the handle movement function, let's go to this one. And basically what we want is over here we are moving the transform position directly. And again, remember this function is going to run on the local client. Every client is going to run this, whether they are the server or just a regular client. And to make this server auth, we need to make sure that only the server runs this code. So how we can do this is basically do a server RPC to tell the server where we would like to move. Now, if you don't know what is an RPC at all, make sure you watch my netcode video. Basically, it's a remote procedure call, meaning it's a way to run code on the server or the client from another place. So here the clients will tell the server where they would like to move. Also, by the way, for this section, I'm going to rewrite this code to make it server auth, but then I'm going to come back to this state. The rest of the game will be client auth. So if you're following along, there's no need to follow this part. So for that, we're going to have a function like handle movement, call it server auth. This one is going to run on every client. So on this one, all we get is the input, and then we're going to send the input to the server. So we're going to do that with an RPC. So private void handle movement server RPC. And on this one, we are going to receive a vector 2 for the input vector. Then we need to mark this as a server RPC. Up here, we are going to call this function and pass in the input vector. And then down here, we're going to run the exact same code. So I'm just going to copy all of this. So just copy and paste the exact same thing. So we get the input, convert it into a move direction, and then the server itself is actually going to move the object. And that's really it. That's how you make it server auth. So let's go up here. Instead of running this function, let's run the one with server auth. Okay, that's it here. Then in the editor, let's just go into the player. And once again, let's remove this one and add the other one. So the network transform, let's add the regular one. This one is server auth. And again, the same thing. And now we can test. So here we are, and if the host moves, and yep, everything does move, that's correct. And down here on the client, if the client does move, and yep, it does still move. All right, awesome. So in this case, making it server auth is actually pretty easy. The basic idea is you only actually modify the game state just on the server. The clients can make some requests, but the server is the final source of truth. Now let me talk about the differences between server and client auth and why you'd want one versus the other. The obvious pro for server auth is security. If the server is the only source of truth for the game state, that makes it much more difficult to hack the game. The server gets requests from the clients and then can validate those requests to see if the values are valid. Meaning, for example, if the client down here, if it tries to move onto an impossible position, the server can just say, nope, you cannot move there. Whereas if the game is client auth, with that, technically a hacker could modify the game files to change something like the player speed and make the player move much faster. Since the server would just receive and accept the player position, that would actually work. A hacker could modify the game and suddenly the player can walk through walls because the server just accepts whatever the client gives it. But if it is server auth, then the client just sends an input, and if that input has a bit of a weird magnitude than is expected, if so, then the server can just revalidate that input, and that way the hacker can no longer move faster than expected. So when it comes to multiplayer, the big question is really about trust. So do you want to trust the client or not? If you do, and the client is malicious, then they might break the game, they might get some infinite money or just walk through walls. So with that said, you might be thinking that means server auth is the way to go all the time, but the answer is it really depends on what kind of game you're making. Server auth also has some downsides. Building a purely server auth game really requires quite a bit more complexity. You need to validate every single input and everything coming from the player. That really complicates things, so there is a cost to making it server auth. It does require some effort. One example as to how server auth is much more complex is simply with regards to client-side prediction. So right now the game actually looks pretty normal. The movement looks pretty good, so I'm moving around over here on the client and everything does seem pretty correct. But that is really because I'm only hosting the game locally. So right now I'm seeing pretty much no lag. Now thankfully the Unity transport over here actually has some nice debug fields. We can, for example, over here put 500 milliseconds of delay to test the difference. So now here I am playing with the same server auth, and if I move on the server over here, the host is nice and responsive. Everything works fine because this one is actually the host, so as I move, it does move automatically. However, down here on the client, I'm going to press the button hard so you can see. So move, and yep, look at that, it takes half a second for the player to actually move. So I press the button and it takes 500 milliseconds before that one actually responds to input. Now if you launch your game like this, every player would find this completely unacceptable. You cannot have the player press a button and then have to wait a long time for the changes to reflect in their own build. So if you implement server auth, then you absolutely must implement client-side prediction, which is a pretty complex topic. Basically, you would need to create just a local object. Then when the player presses a button, you would move that local object to where you think it will be when the message actually gets to the server. Whereas if you just make it client auth, you don't really have to worry about any of that. The client updates automatically and then the changes are sent to the server. So when working on games kind of like this, something casual and co-op, for this, client auth is usually simpler and will work just as well. People will be playing in co-op with their friends, so if a friend really starts cheating, they will just stop playing with that friend. In the end, the basic general answer is, if you're building some kind of PvP competitive game, then you probably want to go with server auth to stop cheaters. But if you're making something co-op, something more for fun rather than competition, then in those cases you're probably best to go with client auth. Now this game is exactly that, it's a casual co-op game, so for this game I won't be going with the client auth approach. So with all that said, let me revert back the changes to make it client auth. So over here I'm going to get rid of this function and go back into the general handle movement. And down here, I'm just going to take these, and both these functions, get rid of them, so exactly the same as previously. Then back in the editor, on the player, let's once again remove this one and add the client network transform instead. Same thing, let's not synchronize all of these. And finally on the network manager, down here, let us not add some debug delete. Okay, so let's test again. So here I am, if I move in the host, yep, everything works. Down here on the client, move it, and yep, everything still works. All right, awesome. So here we'll learn how to synchronize basic layer movement, and importantly, we also learn the differences between server and client auth, and which one you should choose depending on what game you're working on. Now like this, so far we only have the movement synchronized, our nice animations aren't actually playing, so let's solve that in the next lecture.